Welcome back. This is week 27, ICP, Mr. Libby here. We got 5 steps in this week's learning plan. What I need you to do is need to go to Net Forces. I need you to open it up, and you will see that there is 105, 205, 305, and 405. Step 105 is the planner. If you would like to see some slides on this, there's a click there, but this is what we're doing on the first day. That would be Monday, Wednesday, and this is what we're doing on Tuesday, Thursday. On your own, you're going to do the CK12 page. Nothing new there. All right, so let's go to the Net Forces page 7 notes. So Net Forces, it says you're going to put these in your notebook, copy at least what's blue, and there are boxes to type on this slide and slide 7, so you need to do that before you turn it in. So forces are pushes or pulls, and a force has a direction. So it's a vector. Forces can cause resting things to move or cause moving things to rest. So if in the absence of any forces, if something is moving, it'll just keep moving. Think about the movies like Apollo 13 or whatever the one that Matt Damon was on Mars on. I forget what that one's called. But think about the movies in space. If you just let something go, it just sits there. Or if it's moving, it just keeps moving because there are no forces acting on it until it hits something. Unfortunately, on Earth, we can't do that because we have gravity, and that's a force that acts on everything. So gravity is a force. It can cause resting things to move, it can change speed, and it can cause things to change direction. So you're going to go through here. When we do forces, newtons is a perfectly acceptable force. The problem with newtons is that this is a newton right there, and it's got pieces of it. So if I take newtons and divide it by kilograms, I need you to know that that's meters per second squared, because kilograms will go away. If you just write N, you don't see that. So I'm going to ask when you write newtons, especially in the beginning, write it like that. Forces can be represented by arrows. Arrows are not the forces themselves. They're the representations of the force. And obviously, the bigger the arrow, the bigger the force. The smaller the arrow, the smaller force. And arrows have direction. So that's how you can represent the force as a vector. The net force is you just add it up. Just like the net paycheck is everything, it's your hourly pay minus whatever they take out. That's your net pay, that's what's on your check. Net is what's left at the end. So the net force is after you add up all the forces, what's left at the end. And this is how to add them up. So you're going to put this on page 7 of your notebook. Slide 7 has things to add, type on. So if you have 2 newtons pushing to the right and 5 newtons pushing to the left, which one is bigger? The one pushing left, and by how much? By 3 newtons. So you would write, get in there. You write 3 newtons to the left. Right? Pretty easy. Right. Step 3. What type of force is this? This is going to be a pushing up. The thrust is pushing it up, and it's a change in speed. Once you get them right, they'll turn green. There's a couple more things to do down there. All right. This is a website you need to go to. So you're going to get to Tug of War, go to this website, and then do this. Create a scenario, and then take a screenshot, put the screenshot there. And there's things to type. Create another scenario, type. The net force video is pretty good. So our net force simulation is pretty good. You like it. And the last one, this is the CK12. You read the web page. There's a couple of videos to watch. And then down here, there are questions to answer, and then do the adaptive practice. The adaptive practice is this green button on the website. I just can't make it work with a link. And if you have questions, please come to office hours. There is also tutoring available Tuesday and Thursday after school. They'll feed you, and they'll take you home. If you have questions, please ask, and I hope this helps.